Hello friends, today I will solve a LeetCode medium problem on strings. So the problem says, in English we have a concept called root which can be followed by some other word to form another longer word. So let's call this word derivative. So for example, if the root is help and it is followed by the word full, we can say it forms a derivative that is helpful. So we are given a string consisting of many roots and a sentence consisting of words separated by spaces. So we need to replace all the derivatives in the sentence with the root forming it. And if a derivative can be replaced by more than one root, so we will replace it with the root that has the shortest length. And we need to return the sentence after the replacement. So let's understand this problem with an example. So I will consider the first example. So I have taken the first example. So we are given a dictionary and the dictionary contains the root words. And we are also given a sentence where we need to replace each word with a root word. So basically each word we can consider it as a derivative or we need to find its root in the dictionary. So if there is a root present, we need to replace the derivative with the smallest root, and if there is no root present in the dictionary, we'll keep the word as it is. So first let's understand what do we mean by the smallest root. So let's say there was another word in the dictionary called CA. So you can see for the word cattle, we have two roots, the string CAT and the string CA. So the smallest string will be root CA. And the root for a string is a substring that starts from index 0. And we need to consider or replace the string with the smallest root if there are any. Otherwise, we'll keep the string as it is in the result. So let's go through the each word in the sentence. So for the first word, the, there are no root, so it will be as it is in the output. For the second word, cattle, we can see the root will be CAT. So in the output, cattle will be replaced by cat. Similarly, the next word, words, there is no root in the dictionary, so it will be kept as it is. For the next word, rattled, we can see there is a root, rat, rat, so it will be replaced by the word rat. Then the next word, by, so there is no root for the given word, so it will be kept as it is. Then the next word, the, so it will be kept as it is, the. Similarly, the next word, battery, for this there is a root, so it will be replaced by string bat. So the output will be the space cat space was space rat space by space the space bat. So what we are doing, for each string we are searching in the dictionary if there are any substring present and that substring should start from the index 0. So basically we are searching a string in the dictionary. So the data structure we can use here to optimally search a string in the dictionary is trie. So to construct a trie, so I need to construct trie from given dictionary. So this is the pre-processing step. So let's discuss the structure of trie. So each trie node contains two fields, a boolean variable called isEnd. So isEnd will be true if that node is end of one word. And there is another field called children. So the children is initialized to an array of size 26. 26 because in the problem it's given that the string contains only lowercase English characters. So let's create the trie from the given dictionary. So first I will take the word cat. So I'll create a root, and for root the end will be false, and I'll first take the string cat. So from the root you can see there is a children's array of size 26. So I'll take the first character C. For character C, the index will be in the children array, it will be 2. So we can see the children of 2 it will be null. So I'll create a new node for character C. Then I'll go to this new node and then I'll go to next character A. So here it will be initially false. Here I can see from this node there are no other nodes. So I'll create another node for character A. So that will be children of index 0. Then I'll go to next character T. I can see in this node there are no other nodes. So T will correspond to index 20 in the children's array and it is null. So I'll create a new node for that. So the age end will be false. So the characters are mapped to the ages of the trie. So I'm currently at this node and the age end variable is set to false. Now I don't have any character. So I can see this is the end of the given word. So I'll mark each end variable to true. Similarly, I will take the next word that is bat. So I'll start from the root. I can see there are no edges for character B. So B corresponds to index 1 in the children's array. So I'll create a new node for that. So I'll create a new node for character B. Each end will be false. Now for A, there is no edge. So I'll create another node for character A. Then I'll come to this node. Then I'll go to character T. So here there is no edge for character T. So I'll create a new node. Now I have reached the end of the string. So I'll mark this node as end of a word. So I'll mark it to true. Next, I'll go to next word rat. So for rat, I'll start from the root. There is no edge for character R. I'll create one. Then I'll go to next index A. There is no edge for character A. I'll create another node for that. Then I'll go to next character T. There is no edge for that. I'll create another one. I'll mark it as false. And I can see this is the end of the word. So I'll mark each end variable to true here. So now I have constructed my trie. Now let's go through each word. So I'll start from the first word, the. I'll start from the root of the trie. I can see from the root there are no edges starting with T. So I'll stop here. I can see. So there are no prefix words that start from index 0 of the given word, the. So it means there are no roots for this word. So it will be as it is in the output. Then I'll go to next word, cattle. So I'll start from the root. I can see there is an edge for character C. Then I'll go to next word A. I can see there is an edge for A. Then I'll go to the next node. Then I'll go to next character T. I can see there is an edge for T. And here I can see the agent variable of the node is marked as true. So we can say, so there is a root word in the dictionary. And so the root word is CAT. So I will replace the word cattle with the root word CAT. Similarly, I will go to the next word watch. So I'll start from the root. I can see there is no edge for W. So I can say there is no root keyword starting with W. So was will be in the output as it is. Then I'll go to the next word rattled. So I'll start from the root and I can see there is a edge for character R. Then I'll go to the next character in the word. So here I can see there is an edge for character A. Then I'll go to next character. I can see there is also an edge for character T and I'll reach here and I can see the agent is true here. So I can say there is a root word rat. So I'll replace the word rattled with the root rat. So now I'll take the next word by. So now it will be interesting. We can see for character B, I'll start from the root. I can see there is an edge for character B. Now I'll come to this node. Then I'll go to the next character. For Y, there is no edge. So the agent variable is false. So I can say there is no word in the dictionary which is prefix of the word by. So it will be replaced as it is in the output. Then I'll go to the next word the. So the will be replaced by the because we have seen it here. Then I'll go to the next word, battery. So I'll start from the root. I'll go to this node. Then I'll go to next character A. I can see there is an H for character A. I'll come to this node. Then I'll go to next character T. I can see there is an H here from this node. So I'll come here. I can see the each end variable is true. So it means there is a word called bat in the dictionary. So the battery will be replaced by its root bat in the output. So the output will be the, then cat was rat by the. So the output will be each word separated by a space. So now let's consider the second example. So from the dictionary, first I'll try to create a trie. So I'll start from the root. The agent will be false. So I'll take the first string A. So there are no edges for character A. So I'll create a H for character A. Now I can see there are no more letters to process. So this is the end of the word. So I'll mark this node as true because this is the end of the string A. Then I'll go to next string B. I'll start from the root. I can see there are no H for the character B. So I'll create another H for character B. And I can see this is the end of the word. So this node will be marked as true because it's the end of the word. Then I'll go to the next string C. From the root I'll start. I can see there are no H for the character C. I'll create a H for character C. So I'll mark this node as true as it's the end of the word C. So now let's go through each word of the sentence. So the first word is AATSFASF. So I'll start from the character A and I'll start from the root of the constructor trie. So I can see from the root there is an H. So now I'll come to this node and I can see the end is marked as true. So you can say there is an root string A. So I'll replace the word with its root A. Now I'll go to the next word ABSVS and I'll start from the root of the trie. So I can see there is an H for character A. So I'll come to this node. I can see its end is marked as true. So we can say we have a root string A. So I'll replace the given string with its root A. Now I'll go to the next string BBAB. So I'll start from the root. I can see there is an edge for character B. Now I'll come to this node. As it's marked as true, I can say there is a root word B. So I'll replace the given word with its root B. Now I'll go to next string CATSFAFS. So I'll start from the root. I can see there is an edge for character C. Now I'll come to this node. The each end is marked as true. So I can say there is a root word C. So I'll replace the given string with its root string C. So the output will be A, A, B, C. So each string is separated by a single space. So what we are doing in the problem, first we are creating a trie from the dictionary. So then I am going through each word of the sentence, and for each word, if there is a root present in the trie, I'll append that root to the result. And if there is no root for the given word, so I'll append the word as it is to the result. So at the end, I'll return the result. So let's say there are total m characters in dictionary and there are total n characters in sentence. So for example, in the dictionary, we can say the total characters are 3. So m will be 3. So in the problem, what we are doing, we are inserting a string into the trie and we are also searching for a string in the trie. So inserting and searching in the trie takes big O of length of the word. So let's discuss the time complexity. So first we are creating a trie from the given dictionary. So creating the trie will take order of m. So m is the total number of characters in the dictionary. So first I'll find each word. So each word is separated by space. So I can find the word in order of the length of the word time. And to search for the root for the given word in the trie, it will take order of length of the word. So I can say for each word, the time is linear. So for all the words, the time will be big O of n, because n is the total number of characters in the string sentence. Now I will discuss space complexity. So to create the trie, at the worst case, I may need to create a node for each character. So at the worst case, I may need m trie nodes. So it will be big O of m plus I am creating a result string builder to append the strings. So at the worst case, let's say no word has a root present in the trie or present in the dictionary. So I'll append each word to the result variable. So it will take at the worst case n spaces. So it will be big O of n. So I can say the time is big O of m plus big O of n, and the space is big O of m plus big O of n. Now let's go through the code. So first I'm creating a structure trie node. So each trie node contains two fields, a boolean variable called each end to mark the end of a word, and we have also a children's array which is of size 26. So the children's array corresponds to each character and it will point to the next trie node. So this is the function to insert a string into the trie. So I am passing a root and a string and the character index of the string. So if I have reached the end of the string, so if the index same as the length of the string, I'll mark the agent of that root as true and I'll return. Otherwise, I'll find the index of the children's array. So let's say if the character is B, so the index in the children's array will be B minus character A, that will be 1. So I am storing that in the variable I. So I'll check if there is already an existing edge for that character. So if root dot children's I is null, it means there is no edge for that character. So I'll create a edge for that character and I'll store it in the children's of I. Then I'll call recursively for that children and I'll increment the index. Then let's discuss another method called find root size. So what this method does, so given a string, it will search for the root word in the trie. So if we have a root for the given string, it will return the size of the root word. Otherwise, it will return -1. So I'm passing the root of the trie and I'm also passing the string s and the current index in the string s. So I'll first check if the agent is true for the given root. We can say this is the end of the word in the trie. So we have found a root. So I'll return that index. So it means we have a root of size index for given string. Now I'll check if I have traversed the full string, then I'll return -1. It means there is no root for the given string. Then I'll find the index for the children's array. I'll check if there is no edge for the current character. We can say there is no root present. So I'll return -1. Then at the end, I'll call recursively for the current edge, that is root.children's I. Then I'll increment the index. So this is the method we need to fill. So first I'm creating a trie node. Then for each string in the dictionary, I'm inserting into the trie node. So the parameters are root of the trie node, the string s, and the starting index of the string s, that is 0. So I'm creating a string builder result. Then I'm going through each word of the string sentence. So I'm splitting the sentence string. So the split parameter is a space. So string sentence dot split returns a string array, and I'm using enhanced for loop to traverse this string array. So I'll traverse each string of the string array returned by the split method. So for each string, I'll try to find the root size. So I'll pass the root of the trie, the string, and I'll pass the index 0, that is start character of the string. So if there is a valid root, then it will return the root size. that is the size of the root string. Otherwise, it will return -1. If the root size is -1, then there is no root for the given string. So I'll append the string as it is. Otherwise, I will append the root. So it will be basically substring starting from the index 0 and the size of the root. And at the end, I'll append a empty space. And here I'm deleting the last empty space because so after appending a string into the result, I'm inserting an empty space. So at the end, there will be an extra empty space which we need to remove. So I'm doing that in this step. And at the end, I'm returning the result as a string. So now let's run the code. So first I'll run it for the sample test cases. So you can see the basic test cases are running fine. Now I will submit it. So you can see it's working as expected. Thank you.